Doing 4.3, and 4.3 is on quadratic regression. Now there's all kinds of regression. If you go to your calculator, and you go to stat calculate, we've only scratched the surface. We only did one of these. We did lin reg. Do you remember doing lin reg? And that's because our dots were in a line and we found the best line. What happens if my dots do this? Watch. Oh, should I find a line for that? No. There's quadratic, there's cubic, there's quartic. We have natural log, exponential, logistic, sinusoidal. There's so many different things to do. So many things out there that you don't know about just yet. It's exciting. Okay, so here's what we're going to do. We're going to graph the data on our calculator. We're going to label the x and y axes, the scales, and we're going to plot our points right here. So we're going to put time is going to be L1, and temperature will be L2. So do you remember how to do this? Yeah? Go to Stat, Edit. You might have things in your lists from previously. Where's your calculator? Do you need to borrow one? Here. I've got this yard sale one. I got this at the yard sale for $5.
You got a charger?
That doesn't need a charger. I don't have that fancy kind. Everybody else has one? We're good? Okay. Go to Stat and Edit. And you can clear your list by going up to the top of L1 and hitting Clear Enter. Clear Enter. Don't hit Delete. Clear Enter. Okay, and let's go ahead and list the time. And the time's in military time, because you couldn't go from noon to 1. Your numbers wouldn't be right. So 8 a.m., 10, noon. What's 1,400 hours?
That is 2.
2, 4, 6. Now this is weather. And as you know, you woke up this morning and it was freezing outside. It was like 65, right? Brr. So cold. Yeah. And then as the day goes on, it gets warmer and warmer, but then it's going to cool down tonight, okay? Yeah, parabola. 52. It's actually more of a sine wave. See that up there? Because it actually does it the next day and the next day. Yeah, cool, huh? But we're just going to do it for one day, which is a good parabola. All right, so you input all those. Make sure you go to y equals, clear anything that you have there, and turn your plots back on. You probably have them off because you're not doing this, and you haven't been doing this in a while. So turn your plots on by hitting Enter, and then if they're dark, they're on. Okay? And we want to get a good window. Right now, you probably have, a basic standard window, and your points aren't going to show up there. So we want to hit Zoom. Does anyone remember? 9, yes. You can actually press the button 9, or you can scroll down to Zoom Stat, Zoom Statistics. And there it is. You got it? Good. Okay, so let's transfer our points over here onto our paper. And it looks linear for a while because that's what it is. They're constantly increasing. But then you get to a point where you start to come back down. Okay? Are you better at drawing on the iPad than I am? Yeah. Yeah? You're all yeah for sure. Okay. So, and then it also says in letter A to label X and Y scales. Where am I going to find that information? Starts with a W. Good. Window. Window. So my window says my X min is 7. So I'm going to write 7 to 19. The max is 19. And the Y min goes from 47. You don't have to put decimals in, to 86. You can just round, okay? All right. Now letter B. What is the quadratic model for this data? Here we go. Go to Stat. Over to Calc. Number 5. Yes, we've been doing 4, which was linear, but this is quadratic, quad reg. Hit Enter. Some of you have to hit Enter a few times, but there it is. Yeah?
How did you find the minimums again?
Ooh, the minimum?
Like the X and Y.
Yeah, no. Wait, the scales?
Yeah, the 40.
Window. Press the window button. Yeah. Once you hit zoom 9, it'll give you the window, and then it'll change your window values too. Okay, look at that r squared, 0.99. That's really good. That's close to 1. And this isn't r, it's r squared because it's a parabola. R squared, okay? All right, so A is this, B is that, C is that. Let's round to 3 decimal places, okay? And write it out. So y equals negative 0.469. That's A, that's in front of x squared. Okay? Plus 14.716, that's B, that's in front of x. Is your calculator dead?
No, my phone kept buzzing.
Oh, but why aren't you doing these, are you?
Yeah.
Oh, okay. Your phone kept buzzing? Are your drugs ready? Perfect timing. It is Friday, so. Okay, I just recorded all of that. That's weird. Whoops. All right, so there you go. There's our equation. Now, let's put our equation in our calculator in the y equals to graph it and see what it looks like. Okay, so there's 2 ways to do that. Go to y equals. You can either manually type it in, or you can do that fancy way. Do you remember the fancy way? Vars, yes.
I got vars.
You go to vars, and you arrow down to number 5, statistics. Go to vars, statistics, and then over to equation. And number 1 is reg equation. That's any regression equation you choose. If we did a line or quadratic or whatever sign, it would put that in for you. Now my calculator stops. I don't know why, but it always has. So I have to type it in manually. I know. Did yours do the whole thing? Yeah. I don't know. Something's wrong with my calculator. Yep. But it's okay. That's the other way to do it, though, is to just type it in manually. Okay? And then hit graph. Ooh, looks good. Oh, it doesn't quite make it to that top point, does it? We're going to talk about that when we find the... I know. Okay, so let's draw that in. It goes right through these, but it misses that point. You're right, like that. That's what the equation does. Okay. Now, part C says to do this. Use your model. Okay, that's the important question. Use your model to predict the high temp for the day. Not look at the table, not look at your graph, but use the model. The model is this right here. It's this equation. Now, I want to predict the high temperature of the day. The high temperature is the maximum. The maximum is the vertex. So I'm going to, for a standard form, find the vertex by doing x is negative b over 2a. So do negative 14.716 over parentheses 2 times negative 0.469. That's not going to give me the high temperature. What does that give me? Your x coordinate. That gives me the time of day. See, time is L1, time is x, temperature is y. But that's going to get me closer. So do this. On your calculator, do negative 14.716 divided by parentheses 2 times negative 0.469, end parentheses, hit enter. You should get about 15.7. But now we have to plug that back into our equation to find out what y is. Do you remember on the video when I told you to use that answer button? Did you like that at all? Did you do that? Let me tell you I'll show you again how to do that. So do negative 0.469, and now we need x squared. We need 15.6886993 squared. So I can hit second negative, which gives me that answer, and I hit the squared button. Okay? Plus 14.716 times the answer minus 36.121. Hit enter, and you get a temperature of 79.3 degrees. That really wasn't the high of the day. It reached 81. But look at, according to our model, do you see this right here? This graph? The high's underneath that, isn't it? It was only 79. So according to our model, we're right. That's the correct answer. That's not really the correct answer at the high of the day, but it's okay. All right, I want you to try number 2 by yourself. If your calculator's not working, please let me know. Do you want to borrow mine? Oh, yours is working. All right, so we graphed it on our calculator, and then what you want to do is you want to plot the points as best you can on your paper. It looks very parabolic. I think that's the right way to say it. And then it says label, oh, don't forget to label the X and Y scales. So mine goes from 9 to 81 and about 20 to 32. Somewhere around that area, okay? What is the quadratic model for the data? You go to Stat Calc number 5, Quadratic Model, and we'll round to 3 decimal places again. You should have gotten y equals negative 0.008 x squared, because that's the a in front of your x squared, plus 0.746x plus 13.469. And that's your model. That's your quadratic model for this graph. And then if you want to check to see, you want to draw the parabola on your graph, you would go to y equals bars, statistics, regression equation. And there mine messes up again. Or you can just put it in yourself, okay? Plus 0.746x, 13.469. All right, and once you hit graph, you'll know that it's right because it goes through a bunch of those points. Look how good that is. That's really good. Okay, so it looks like this, and it goes above and down, something like that. Pretty good. Now, the last question says, use your model to predict the speed at which the mileage is the greatest. We don't have to go back and plug it in. They want speed, so they want the x value this time. So we're going to do the maximum happens at the vertex. Negative b 0.746 over parentheses 2 times negative 0.008. And let's find out what that is. Negative 0.746 divided by parentheses. Don't forget to put parentheses around that whole thing on the bottom. 2 times negative 0.008. And I get that it's about 46.625 miles per hour. Did you get that? Yeah? Okay, if you look over here at the table, you can see that the most mileage that you get is about 30 something, and that happens in this area between 40 to 55 miles per hour, and then we found it ended up being 46, so it's right in there. It's pretty good.